In the spring of 1943, deep inside a restricted testing ground outside Berlin, a group of German engineers gathered around something unexpected, a tank that didn't belong to them. It wasn't a Tiger, nor a Panther. It wasn't even German. Before them stood a captured American M4 Sherman, covered in battle dust, its olive drab paint scarred and blistered from weeks of combat on the North African front. They had seen enemy machines before, crude, often inferior, occasionally impressive. But this one was different. The men were silent at first, circling the tank like surgeons, examining a body they didn't understand. One of them, Oberingenieur Karl Ruprecht, a veteran designer who had worked on both the Panzer IV and early Panther models, muttered under his breath, "It looks simple." Another replied, almost dismissively, "Too simple. The Americans build tractors, not war machines." They all laughed, until they turned the key. The Sherman's radial engine came alive, smooth, constant, without the sputter or choking hiss common in their own machines. The laughter stopped. What followed was not a demonstration of speed, nor firepower, but endurance. The engineers drove it for hours across the testing ground, through mud, over rocks, up inclines that even a Tiger would hesitate to climb. The Sherman just kept moving. When they opened its engine bay, they found nothing extravagant, just well-placed components, accessible bolts, and a cooling system that looked almost agricultural. Yet it worked, every time. And as the test continued, a quiet realization began to spread among the men, an uncomfortable truth. This enemy machine, built in American factories by workers who'd never seen a battlefield, was doing something German engineering rarely achieved during the war: reliability. They came to test a captured tank. They left questioning their own designs and their own doctrine. But to understand why this moment mattered, we must go back to the early years of the war, when German tanks ruled Europe and arrogance ruled German engineering. In the early years of the Second World War, Germany seemed unstoppable. Its panzer divisions sliced through Europe with terrifying precision. France fell in 6 weeks. The Blitzkrieg had rewritten the rules of modern warfare. Behind that speed and coordination was a weapon that had become a symbol of German might: the tank. From the nimble Panzer III to the workhorse Panzer IV, these machines were products of an engineering culture that worshipped perfection. To German engineers, a tank wasn't just a weapon, it was a masterpiece. Every gear, every weld, every optical sight was crafted with almost obsessive care. They built tanks the way one might build a fine watch: precise, complex, and delicate. That philosophy worked at first. But war, as they would learn, doesn't reward elegance. It rewards endurance. By 1942, as Germany faced the brutal winters of the Soviet Union, cracks began to appear, literally. Tigers and Panthers, once symbols of mechanical supremacy, were breaking down faster than they could be repaired. Tracks froze solid, engines seized, gearboxes failed under cold and mud. And while German workshops struggled to maintain a handful of operational tanks, the Soviets and Americans were churning out thousands. The German war machine was producing marvels, but marvels that couldn't set last. In Detroit, the philosophy was different. American designers didn't chase perfection, they chased production and reliability. The M4 Sherman was the embodiment of that mindset: easy to manufacture, easy to repair, and above all, easy to keep running. It wasn't set the strongest tank, nor the best armed, but it had something Germany had forgotten how to design for: sustainability. While German engineers debated tolerances in microns, the Americans were building tanks by the thousands, each one standardized, modular, and rugged enough to fight across any continent. When the first Shermans reached North Africa, German tank crews mocked them. They called them Ronsons, like the cigarette lighter brand, claiming they lit up the first time every time. But the laughter would fade, because as the war dragged on, those same Shermans, crude, simple, relentless, just kept coming. It was only when a handful of captured Shermans were brought back to Germany for testing that the truth began to dawn. German engineers, men raised in a culture of mechanical pride, were about to confront a machine that defied everything they believed about design and superiority. They were about to discover that brilliance means nothing if it can keep moving. They were not soldiers. Not in the sense of the frontline men who froze in the mud or burned in tank turrets. These were the thinkers, the craftsmen, the intellectual backbone of the German war machine. Engineers, designers, test officers. Men of pencils and slide rules. And like all true engineers, they took pride in perfection. At the head of the team stood Oberingenieur Karl Ruprecht, 52 years old, an engineer since the days of the Reichswehr. He'd helped develop components for the Panzer III, and later consulted on the Tiger's engine systems. He was precise, cautious, a man who measured success in tolerances, not victories. To him, a tank was a statement of German superiority, the mechanical embodiment of discipline and intellect. Yet even he could not ignore the orders that had come from above. A captured American Sherman from Tunisia was to be tested thoroughly, functionally, structurally, and operationally. Berlin wanted answers. Among the younger engineers was Leutnant Feldmann, 26, whose brother had been killed on the Eastern Front when his Panther's final drive failed in combat. For him, this test wasn't just technical, it was personal. Each man came with a different expectation. Some were curious, some were skeptical, and some, quietly, were afraid of what they might find. Because whispers had already begun circulating through the engineering circles, rumors from the front lines, that American tanks didn't stop, that they crossed rivers and deserts with the same reliability, that they could be repaired with a wrench and a hammer in the field, while German tanks required an entire workshop. Ruprecht opened the Sherman's engine bay, expecting complexity, perhaps chaos. Instead, he found order. The layout was clear, the components accessible, the wiring logical. He noted it with silent irritation, as though simplicity itself were an insult. Later that day, during a break, Feldmann sat on an ammo crate beside the Sherman, running his hand along its side armor. He whispered to another engineer, "If my brother Sept's tank had been this simple, maybe it wouldn't have failed." No one replied. It was the first crack in the armor of pride, small, but growing. By dusk, they had catalogued every feature, its welded hull, its suspension, the cast turret, the radial engine borrowed from aviation design. Everything about it spoke not of elegance, but of purpose. As the engineers packed their tools and notes, Ruprecht lingered behind. He looked at the Sherman still standing, engine ticking softly as it cooled. He wrote a single line in his report that evening: "Design philosophy, alien, yet effective. Must investigate further." They didn't know it yet, but this humble enemy machine would soon make them question not only their engineering, but their entire belief in what German superiority truly meant. May 1943. For the German engineers, this was more than an evaluation. It was an autopsy of the enemy's craftsmanship, a chance to prove that American simplicity was just primitive. They were certain the Sherman's flaws would reveal themselves within hours. The tests began with a drive endurance trial, 20 kilometers across uneven terrain, followed by gradient climbs and suspension stress runs. The Sherman moved forward easily. Its radial engine roared but never faltered. Its transmission, a 5-speed manual, shifted cleanly, without the grinding the engineers had come to expect from their own machines. They pushed harder, inclines, ditches, loose soil. Still the Sherman climbed, rolled, and recovered. After 2 hours, one mechanic turned to Ruprecht. "The oil pressure hasn't dropped. Temperature stepped steady. Fuel use, normal." Ruprecht frowned. "Check again." They did. Same results. By midday, the German test drivers had started murmuring, quietly at first, then openly. The controls were smooth, the steering intuitive. Even the suspension, the much-maligned vertical volute spring system, absorbed shock better than expected. It wasn't elegant, but it was forgiving. That word, forgiving, stuck with Ruprecht. German machines weren't forgiving. They demanded precision. The Tiger's transmission could shatter if a driver missed a shift. The Panther's engine overheated if revved too long. The Sherman, by contrast, felt alive, adaptable, human. By late afternoon, the engineers decided to push the tank to failure. They overloaded it, forcing the engine to drag nearly double its standard weight. They ran it through mud deeper than regulation tests allowed. They drove until the treads smoked, the oil thickened, and the fuel ran low. And still, it moved. The Sherman groaned, hissed, clattered, but it didn't stop. Finally, one of the engineers, Feldmann, climbed down from the driver's seat, hands trembling with exhaustion and disbelief. "It shouldn't be possible," he said. "Its stut's not built like ours. Its stut's too light, too basic." Ruprecht stared at the machine, mud-caked and dented, but still functional. "Basic," he repeated. "Yes, and yet it endures." That evening, in their barracks, the men compared notes. Their findings defied everything they had been taught. The Americans had achieved something the Germans, for all their brilliance, had overlooked: a tank that could be driven by anyone, maintained by anyone, mass-produced anywhere. The engineers had begun their tests, searching for flaws. Instead, they were uncovering a new kind of genius, one born not of perfection, but practicality. But for the Germans, this realization was not just technical, it was ideological. Their engineering pride was at stake. Their identity as the world's finest builders hung in the balance. And as the next round of testing began, involving live fire drills and armor analysis, the conflict would no longer be between man and machine, but between truth and pride. They had tested the Sherman SIP's endurance. They had tested its mobility. Now they would test its limit. No machine, they reasoned, was perfect. And if the Americans had built something this simple, this unrefined, it would surely crack under pressure. They began with destructive testing. High-impact shells fired from captured German anti-tank guns. Explosive charges detonated near the hull. Repeated stress runs over rock and trench. At first, the Sherman endured it all, dented, scorched, but alive. Its suspension bent but held. The engine, though coughing black smoke, roared stubbornly back to life after every trial. Ruprecht watched with an unsettling feeling growing inside him. Not admiration, not yet, but the slow crumble of certainty. The German doctrine had always worshipped precision. The Sherman worshipped function. And function was winning. Finally, late in the afternoon, after days of punishment, the Sherman stalled during a deep-ditch trial. The right track had jammed. A mechanical failure, minor, but it stopped the tank dead. Ruprecht ordered the crew to open the side access panel. They found the culprit almost instantly, a rock wedged into the idler wheel. A mechanic laughed bitterly. "So it stops for a stone." But then, something unexpected. The American field manual, recovered from inside the tank, showed a detailed diagram on how to fix exactly this. 1 page, 1 wrench, 1 hour. That SIP's all it took. The tank ran again before dusk. For the Germans, used to complex systems that required workshops, replacement parts, and hours of tuning, this repair bordered on sorcery. Feldmann flipped through the manual, reading aloud instructions translated into German by an interpreter. Simple language, direct tone. No jargon, no ambiguity. "Even a farmhand could follow this," he said. To which Ruprecht replied, with a rare hint of respect, that, "Leutnant, may be the point." That evening, over thin coffee in the officers' mess, a quiet argument broke out among the engineers. One insisted the Sherman was a fluke, a statistical miracle. Another countered that simplicity itself might be the innovation. Ruprecht said nothing. He sat apart, staring at his hands, the hands that had helped design the Tiger's gearbox, the Panther's cooling system, and dozens of prototypes that never survived long enough to matter. He finally whispered, almost to himself, "We built machines to impress ourselves. They built machines to win a war." The Sherman had finally stopped, only to reveal a truth that couldn't be ignored. Germany's tanks were masterpieces that died young. The American tank was a workhorse that refused to die. And for a nation obsessed with perfection, that realization was a wound deeper than any shell impact. The testing was complete. 3 weeks of observation, endurance trials, destructive evaluations, and grudging respect. Now came the part the engineers dreaded most, the report. Oberengineer Karl Ruprecht wrote every line with precision, the same precision he had once poured into his blueprints. But this document would not celebrate German engineering. It would quietly, but unmistakably, challenge it. The American Men 4 medium tank demonstrates exceptional mechanical reliability. Maintenance procedures are straightforward. Engine and transmission components are accessible and modular. Field repair capacity, superior. Another paragraph. While inferior in armor thickness and gunpowder, the Sherman achieves combat readiness rates that far exceed current German models. Design favors quantity and function over complexity. He hesitated before typing the final line. It is recommended that future designs consider reduced complexity in favor of production efficiency and operational reliability. Ruprecht knew those words would not be welcome in Berlin. But truth, he thought, was an engineer's only loyalty. When the report reached the Heereswaffenamt, the Army Ordnance Office, it caused quiet discomfort. High-ranking officers, trained to see German technology as the pinnacle of modern war, struggled to reconcile these findings. One colonel reportedly remarked, "We cannot compare our panzers to these tractors. They serve different masters." But others, particularly those managing logistics, saw something different. They saw truth in the numbers. German tank readiness hovered below 60% on the Eastern Front. American units reported 80 to 90%. For every German Tiger that broke down, 2 Shermans arrived at the front lines, repaired overnight with spare parts pulled from a warehouse the size of a city block. In that contrast lay the future of the war. Germany was building excellence. The Allies were building momentum. And momentum, history would prove, is what wins wars. Within the engineering circles of Kummersdorf, word of Ruprecht's report spread quickly. Some dismissed him as defeatist. Others, like Lieutenant Feldmann, saw him as brave. One evening, as they stood outside the testing ground watching the rain fall on the abandoned Sherman, Feldmann said, "They still ignore your report." Ruprecht nodded. "Perhaps, but someday, someone will build a machine like this, and understand why it mattered." The turning point had come quietly, not on the battlefield, but in the mind of a German engineer who finally saw that war was not about perfection, but persistence. While the engineers at Kummersdorf debated philosophy, the front lines were deciding the argument for them. By mid-1944, the war had shifted. Germany's armored divisions were retreating on all fronts, the Eastern Front collapsing under Soviet steel, the Western Front bracing for the Allied invasion that everyone knew was coming. And into this storm rolled the M4 Sherman, thousands upon thousands of them. It wasn't set the best tank on paper. Its armor could be pierced by nearly every German anti-tank weapon. Its 75 mm gun was modest. Its silhouette, tall and conspicuous. But it had something else, presence. Every time one Sherman was destroyed, 2 more arrived. Every time a gearbox cracked, another was bolted in within hours. Every time a crew was lost, a replacement tank and a new crew appeared days later. The Sherman wasn't built to dominate. It was built to endure. And endurance multiplied by numbers became strategy. In Normandy, where German Tigers and Panthers prowled the hedgerows, it often took 5 Shermans to bring down 1 Tiger. But the Allies had 5 to spare. Germany did not. For every Tiger that rolled out of a German factory, Detroit built 100 Shermans. Ruprecht's warnings had been ignored. The cult of perfection still ruled German design. Every tank was a masterpiece, but masterpieces don't win wars. Machines that keep moving do. To the soldiers who fought inside them, the Sherman became more than a vehicle. It was a companion. They named them, decorated them, trusted them. They cursed their thin armor, but they loved that the engines started every morning. Meanwhile, on the German side, tank crews were fighting their own machines as much as the enemy. Fuel shortages, transmission failures, overheating. For every Tiger that reached the front, another broke down on the way. The difference between the Sherman and the Tiger was not just armor and firepower. It was philosophy. One was built to survive the factory floor, the other to survive the battlefield. And when the Allied advance began to move faster than German logistics could react, it was clear which philosophy would endure. The lesson Ruprecht had discovered in that quiet test range outside Berlin was now being written across the map of Europe in fire and steel. Reliability had become a weapon, and no amount of precision could stop it. By the spring of 1945, the sound of German engines, once a symbol of dominance, had become a whisper. Fuel was gone, supply lines were severed, and the tanks that had once embodied German brilliance now stood silent, rusting in the mud. The Reich's dream of mechanical supremacy was collapsing, not in one great explosion, but through 1,000 quiet breakdowns. The Tiger, the pride of German engineering, could destroy any Allied tank in a fair fight. But war by then offered no fairness. A Tiger might kill 5 Shermans, but then run out of fuel before reaching the next village. And when it broke down, as so many did, no spare parts came. No fuel trucks followed. The machine that symbolized perfection had become a stranded monument to hubris. Meanwhile, the Shermans, those tractors, kept coming. They crossed rivers, climbed hills, pulled each other from ditches. Their crews joked that they might not be the best tanks, but they were always there when needed. In the war's final weeks, Allied forces captured the Kummersdorf proving ground, the same place where Ruprecht and his team had tested the Sherman 2 years earlier. Inside the facility, they found the old test reports, typed in fading ink. One American officer leafed through the pages, smiling at a line highlighted in red pencil. The enemy tank displays reliability beyond expectation. Recommend study. He looked up and said quietly, "We already knew." In those final weeks, Karl Ruprecht kept his notes hidden. Not for fear of punishment, that no longer mattered, but because he couldn't bear to see them burned with everything else. In his diary, recovered after the war, he wrote, "We built machines that demanded perfection from men. The Americans built machines that served men as they were." He underlined one final sentence. "Perhaps that is why they will inherit the future." And so, in the wreckage of war, the myth of German invincibility died, not because its engineers lacked brilliance, but because brilliance alone was never enough. The Sherman had proven a quiet truth of modern warfare, that the simplest machine in the hands of many can outlast the most perfect machine in the hands of a few. The war was over. Germany lay in ruins, its cities bombed to ash, its industry dismantled, its once mighty engineers reduced to refugees in their own land. Kummersdorf was silent. The proving grounds that had once echoed with the thunder of engines now lay overgrown with grass and ghosts. To the victors, these hulks were curiosities, symbols of an obsession that had consumed its creators. Yet among the ruins, a quieter legacy survived. In Allied hands, German engineers were interrogated, studied, and eventually employed. Their insights about armor slope, suspension design, optics, would shape the next generation of tanks. But what they remembered most was not the Tiger. It was the Sherman. Inside one folder was Karl Ruprecht's full report. In clear, technical prose, he had listed every advantage the Sherman possessed: ease of maintenance, mechanical simplicity, standardized components, interchangeable parts, and above all, reliability under duress. An American colonel who read it in 1946 reportedly said, "It sits the first honest compliment we ever got from the Wehrmacht." Ruprecht, now grey-haired and thinner, stands before a blackboard, teaching a new generation of engineers. He sketches 2 outlines, a Tiger and a Sherman, and writes above them, "Complexity is fragile. Reliability wins wars." When West Germany rebuilt under NATO, those same men helped design a new machine, one that would blend German precision with American practicality. Its name was the Leopard 1. Light, fast, reliable. It was a tank born from the lessons of defeat, a child of both the Tiger's ambition and the Sherman's endurance. Ruprecht never sought fame. He refused interviews, declining to romanticize the war or his work. In one rare letter to a colleague, he wrote, What we learned from the Sherman was not about steel or oil. It was about humility, that even the finest design must serve the imperfect men who use it. Out of the ashes of arrogance came understanding, and that understanding, the quiet, unglamorous power of reliability, would define modern engineering far beyond tanks. From cars to airplanes, from factories to computers. The lesson was the same: build for endurance. Design for humanity. Because war, like life, rewards not the most beautiful machine, but the one that simply keeps going. We admired the tiger. We respected the panther. But we learned from the Sherman. And perhaps, in that admission, lay the truest victory of all. The story of a captured Sherman tank in 1943 is more than a tale of metal and mechanics. It is a story about priorities, about humility, and about the quiet power of persistence. The German engineers who first tested the Sherman were confronted with a truth that challenged everything they believed. Brilliance alone cannot win a war. Endurance, reliability, and adaptability do. The lesson echoes beyond the battlefield. In engineering, in leadership, in life itself, the most elaborate designs can fail when the simplest solutions endure. The Sherman wasn't the biggest, the strongest, or the most glamorous. But it kept moving, day after day, battle after battle. And in the end, that was enough to tip the scales of history. Karl Ruprecht and his colleagues lived to see the world they had helped reshape. A world where the philosophy of reliability influenced generations of engineers, not just in tanks, but across industries, nations, and decades. Their humility, born of observing a machine built by others, became a legacy far more enduring than steel. History often celebrates the mighty, the spectacular, the unstoppable, but sometimes it is the quiet, steady, dependable things that endure, that carry people forward, that survive the chaos, and that ultimately change the course of events. So the next time you admire a machine, a design, or even a strategy, ask yourself, is it built to impress, or is it built to last? If this story moved you, like, comment, and subscribe for more echoes of history, because in the end, the past teaches us not just what happened, but how to endure.